This is Arvin Vora, founder of Vora Method and author of The Equation for Excellence, How to Make Your Child Excel at Math. In this video, I'm going to show you how to debug your math problem. First, let me explain what debugging is. It's usually used in computer programming, and here's what happens. When you're writing a computer program, you begin by sketching out your logic and your plan. You write up some code, you try to run the code, and 100% of the time, it doesn't work. Something goes wrong. And so at that moment, you need to debug what you've done. You need to find the bugs in your code. And the way that you do that, at least the way that we do that inside the VMH, is you use logging, which means basically you have the computer tell you, the programmer, what any given variable contains at a given time. Now, I've just done a search up here for console.log. In JavaScript, that's how you find, that's how you log something. You use the command console.log and then whatever you want. And you'll see that it appears 1,150 times in the code for the VMH. And that each one of those points is some area where we made some code, something went weird, we had to analyze it much more closely, figure out what the problem was, and then we fixed the problem. And here's just a simple example of what a console.log will look like. This part of the VMH code is for if you're in class, it welcomes you with an image, and then if you say hello again, we don't want to show you an image again because that would just be kind of annoying to see these big hello images every 5 seconds. So this is the process by which we make sure it shows you that thing once, but it doesn't show it to you again and again and again. And this console log shows us the inside of that array, and it lets us see what's actually happening underneath the surface. And we've done this many times. We've gone through many parts of the code, logged the data inside of the program, and then we figure out what to do next. And this is very close analysis. If those of you guys who do computer science already know this, if you're writing a program, you will spend at least twice as long debugging it, if not 10 times as long debugging it, as you do actually writing it. The same thing you'll see in beta testing. If you're beta testing a major program, for example, something that's on the scale of like YouTube, it might take you a year to write, and it might take you 10 years to beta test it. That process of finding the bugs is actually as a bigger process than writing the code. Finding the mistakes is what computer programming is, and it also is what math is. And so when you're doing a math problem, let's say you're doing a math problem, you get it wrong. Now you need to debug your work. You need to see, what did I do wrong? How am I going to figure out what to do next? And so you need to, just as in the code, we look inside of it and figure out what's happening where, you're going to do something actually very similar with your own math work. Let's take a look at this, though. Let's just start with this. If your math homework looks like a graffiti-covered bathroom, it's impossible to debug. You can't debug work that looks like total garbage. So if on your paper you've written the math like diagonally in a corner or sideways or in some illegible writing, just write the math problem again, get a piece of lined paper, write on the lines, because now it's time to figure out what went wrong. In school, by the way, they don't teach you how to debug your math problems. They just do it for you, which is why a lot of you guys don't get perfect scores in math until you go through Vora Method training. This is what it takes to get a perfect score in math. This is what it takes to do advanced and abstract math. It's also what it takes to do computer programming, engineering, economics, writing, fiction. I mean, anything of any note and of any worth you want to do at all, of any kind, is going to require this process, where the follow-up, the debugging, the improving takes twice as long. Writers know that revising their work takes longer than initially writing it. So let's take a look at that. So if your work looks like this, just get rid of it and just rewrite it. Now your work might not look like this. Now, if your work like this, it just means you're just not taking the task seriously. It's going to take you forever. So don't do this. This is just stupid. But let's say your work doesn't look like this. Let's say instead your work looks like this. Here I've written a math problem, and this answer is wrong. But it's impossible to debug this. I couldn't debug this. You know why? Because there's no steps to debug. There's just the question and then a wrong answer. I can't tell where I went wrong. If somebody tells me that it's wrong, okay, I can see that it's wrong, but I haven't broken it down. So even if your work is very neat, if it's on the lines, all that kind of stuff, but it looks like this with no steps shown, then you're not going to be able to debug it. Even if you've shown most of the steps, but a few times you've combined 2 or 3 steps into one step, I can tell you right now, that's where the error is. Wherever you combined the 2 steps into one, that's where your error is. I can virtually guarantee you that. Let me show you what I would do if I was debugging this problem. So I've written the wrong answer here. So the first thing I'm going to do is I'm not going to write the answer, the thing like that. I'm going to rewrite the problem here. Equals 21. And then I'm going to show every single step. I'm showing it to myself. Every single step. I've already found the problem. 3m equals, I do 21 minus 6. 21 minus 6 is 15. I divide by 3. I divide by 3. And I get that m equals 5. So this didn't really require that much. That as soon as I actually made the problem debuggable, in other words, as soon as I made it possible to debug the problem, it already solved it. I mean, I already figured it out right away. That's the key of this. If you're trying to debug a math problem, as in you got it wrong, in other words, your method currently didn't work. It was the wrong method because it did not work. If you got the problem wrong, instead of just saying, oh, I got it wrong, maybe the teacher will help me. That's not a teacher helping you. That's a teacher just making you weak. If you got the problem wrong, it is time to debug it. And the first step of debugging is to write out every single step. Write it out on paper, on a physical piece of paper, and then see if you can spot where you went wrong. And if you have any area at all where you've done 2 steps at once, like combine 2 steps into one because you thought you would save time, well, first, you're not going to save time. It's going to take you 10 times longer to debug it, and you're going to have to rewrite the problem. But if you did that, uncompress those steps, write out every single step one at a time, don't compress 2 steps, and see if that's going to be enough. Chances are that will be enough for you to be able to debug the problem that you're currently on.